Okay, so now let's talk about derivatives. Here we have derivative notation. We call that f prime of x. This would be y prime. All these mean the same thing, but we can also write it dy over dx, which means the derivative of y with respect to x. And then we could also say df dx. And we could also say the derivative of f of x with respect to x. So these are different notations. Really, it's just prime, which is just that little tick mark. And there's also this d something over d something. I prefer, depending on what you're doing, if you're doing something really quick, the primes really work well. If you have a lot of variables happening, you probably want to use the dy dx or something similar so you know what your variables are. Find the derivative using the limit definition. So the limit definition is the limit as h approaches 0 of x squared. F of x plus h is going to equal x plus h squared. And here, I'll write up here the formula that we're going to use. The limit as h approaches 0 of f of x plus h minus f of x over h. So we have f of x plus h, we have f of x, and h is just still going to be a variable. So now let's put it all together. We have the limit as h approaches 0 of f of x plus h is x plus h squared minus f of x, which is x squared divided by h. Notice I keep writing the limit. You have to keep writing a limit. It's part of the notation. So don't let go of that until we actually evaluate it. I'm going to FOIL out x plus h squared, and I get x squared plus 2hx plus h squared minus x squared over h, which is going to equal the limit as h approaches 0. And we can see that the x squares are going to cancel, and I get 2hx plus h squared over h. I'm going to factor out that h over h, and I'm going to end up with 2x plus h. The h's are going to cancel. I get the limit as h approaches 0 of 2x plus h. And now notice when I plug in 0 for h, I get 2x. So we can say f prime of x or df dx or many other things equals 2x. It really depends on where exactly on my curve I am. So if I have, we know this looks just like a parabola. I'll just do it real quickly here at the bottom. So this looks like a parabola. And if I'm at x equals 1 and I draw my tangent line, when x equals 1, the slope of this line is equal to 2 because it's 2x. If I go to -1 and I draw my tangent line here, I can say the slope here is equal to -2 because now we're at x equals -1 and it's 2 times -1. The slope is equal to -2. And it just depends. I can pick it at 0, I can pick it anywhere, and I will know what the slope of the tangent line is at different points along this graph. Again, I have a I'm going to compute the derivative. The derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. I know f of x is equal to the square root of x. F of x plus h is going to equal the square root of x plus h. Now I can just plug everything in. So I have the limit as h approaches 0. F of x plus h is the square root of x plus h. And then minus the square root of x over h. Remember, we multiplied by the conjugate. So we can multiply by the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. And then I get the limit as h approaches 0. And now we're really multiplying the conjugates, which means what we're doing is saying a minus h times a plus h, or let's make it b so we don't get the h's confused, equals a squared minus b squared. So that's now what I'm going to do here. This is going to be the square root of x plus h squared minus the square root of x squared over h times the square root of x plus h plus the square root of x, right? So I just multiplied it out, which equals the limit as h approaches 0 of x plus h, because this cancels, minus x over h times the square root of x plus h plus the square root of x. The x's are going to cancel, and also the h's here, I'm going to have h over h, they're going to cancel, and I'm going to end up with the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x, right? When I plug in h equals 0, I get 1 over 2 times the square root of x. I'll actually make it 1 over 2 times the square root of x. Because remember, this h is going to be 0, so I have the square root of x plus the square root of x. So the derivative, so it says compute dy dx, this equals dy dx. Okay? Now for b, it says find the equation of the line tangent to the graph at 4, 2. We know that dy dx is equal to 1 over 2 times the square root of x. And the question says, find the equation of the line tangent to the graph at 4, 2. So I want to find the equation of the tangent line, basically, at 4, 2. Okay, well, what do I do here? Well, it's not too hard, because all I say is dy dx, which is equal to the slope of the tangent line. Remember, I'll write m sub t, is going to be equal to 1 over 2 times the square root of 4, because my x is 4, which is equal to 1 and over 4, okay? So now I know the slope of my line. I know a point, so I'm going to use point slope. And you can always use point slope. You do not have to change it into intercept form. Point slope is fine. So we get y minus 2 equals m. So point slope is y minus y1 equals m times x minus x1. So I have y minus y1. I only have 1 point, so all my point is 1. And then times m, which my slope is 1/4, times x minus 4, because that's my x. And that would be the solution for B.